Hello and welcome to this session. So in this session, we'll understand how MapReduce works. So we'll take an example. So we have the input file. So we have some data here. Basically, the data about some fruits. So we have apple, we have mango, we have grapes. Now observe here, apple, mango and grapes, all of them are repeating, right? So and all of them are separated by space. So our requirement is basically to find out how many count of apples, like how apple how many times it is appearing, mango how many times it is appearing, grapes how many times it is appearing. So very classic example, the word count example. So this is something that you will see in most of the tutorials. So the word count example is taken to explain how the map reduce works, and we're going to follow the same thing here. Okay, so we have this input file. So our code has to find the occurrence of each word. All right, so now assume that the data is distributed into four nodes. So let's say we have one node here, we got two, we have three, and we have four. So we have four nodes here. Okay, and some part of this data, let's say this data is goes and sits here. This data goes and sit in the second node. Similarly, this data, which is third record, and this data is basically available here, and this data is available in your fourth node. So we have four nodes and data is distributed across the four nodes. So this is something that we know from the HDFS, right? So Hadoop distributed file system. So the data is distributed across multiple nodes. So this is fine. This is great. Okay. Now what happens is, as MapReduce program we have seen in the previous lecture, right? So what happens is that you have this code, and the code will go and executing each of these nodes, right? So the code will execute here. So let's say we have this code. So assume this is the code. So the code will execute here. The same code will execute here, the same code will execute here, the same code will execute here. All right, and then what will happen is, here what we'll have a key value as an output. So we'll have the intermediate output, right? So we'll have a key value output here. So basically every word is taken as a key, and then a value will be assigned. So that's your key value pair. For example, apple is a key, so we want to assign some value, so we assign a value 1. Similarly for mango, we assign a value 1, right? So this happens here. So we have again four nodes here. So we have node 1, so this is your node 1, node 2, this is your node 3, and of course you have node 4. All right, so we have all the four nodes here, right? And what will happen is there will be an intermediate result, which basically is a key value pair, right? So here you have apple and the value 1, then we got mango 1. Similarly we have grapes here, and we have one value here. And here what we have is we have grapes, we got mango 1, and yeah, we have one more record of mango, so another mango. And similarly here we have apple, we have mango, right? And finally what we have here is we have mango, this is one and then we have grapes, and then we have mango. Okay, so this phase, as we know, where we have the intermediate results, so this phase is your map phase, right? So this is your map phase. Now what will happen here is, you have this intermediate data. So you have the count, like apple is 1, mango is 1, grapes is 1. Similarly you have here in all of these different nodes. Now in order to get the final output, we need to bring all of them together in one node, right? All the apples into one, all mangoes into one, or all grapes into one, right? So for that we need to do what we call as a shuffling. So shuffling is basically movement of data from one node to another, right? So here let's say let's take three nodes. So the data would get and reside in all these three nodes. So this node, maybe all the apple data will come and sit here. This node, all mango will come and sit here, and here all grapes will come and sit here. So this phase where we have the movement of data from one node to another, so this phase is called as shuffling. All right, so shuffling decreases the performance because the data has to move from one place to another, but then this is inevitable, so shuffling has to happen, but then they will also see how we can minimize this shuffling in the videos that are coming up later in the course, right? So for now, let's go ahead and say, okay, this one has apple, right? So what will happen is, here you have apple. So here you have apple. So here from this node we have one, count as one, so we'll take as one. So this node does not have any of apple. Here you have one and one, right? And if I scroll here down, here I don't have anything, so that's the apple count. All right, then let's take mango, right? So mango, we got one here. uh, in the second node we got one, you also got one, third node we got one, fourth node we got one. Okay, let's see, yeah, we got one more in the fourth node, right? So we got one more here. So grapes, if I look at grapes, so yeah, I have grapes in my first node. Second node I have one occurrence of grapes. Third node I don't have any grapes, and fourth node I have one grape. All right, so this is your shuffling. So now here after the shuffling, so the code, the final code will be applied, the reducing or the grouping of the data will apply, and then finally you will get the output, the final output. So here you will have the output. So this output would be your apple, and it will count the number of occurrence like 1, 2 and 3. So you have 3 here. So mango, you got 1, 2, 3, 4, 5, 6, you have 6, and finally grapes you have 3. So this phase is called as the reduce phase. All right, so this is your reduce phase, and this is the output that goes to your final client or to the user or to the program that has invoked. So this is how your MapReduce works. So you have map phase where you have a key value pair. So your code is going to get applied on the partial data in each of these data nodes, and then you have a reduce phase where you are going to combine or we can aggregate this data and give the final output. So that was your reduce phase. So MapReduce works on Java. So to use MapReduce, we have to learn Java. But what happened with time is, like, we got many other big data tools, like we have Hive, we have Spark, which do not require us to learn Java, and we will learn them down the line. We'll talk about Hive, we'll learn Spark down the line. But this is basically a simple example of how MapReduce works. I hope you understand this, and I will see you guys in my next class.